guys, it's BJ here. Welcome to my channel. So in this video, I'm going to walk you through how to do a coffee sales analysis. So we are being presented with some business questions by the stakeholder, which we must answer with the coffee sales dataset. So we'll be going over each and every one of these business questions and generate insights from our dataset. So let's dive in. So the first step of every analysis is to ask the business question, which you are being presented with here.
Okay, the library is loaded. So in case if you are not seeing this library or it's not bringing it automatically, and you are using Jupyter Notebook or maybe you are using VS Code connecting to your Jupyter Notebook, so just go ahead and open the terminal. So once you open the terminal, just search or type in conda install. So for Pandas, just use conda install pandas. And for Matplotlib, just put Matplotlib, just replace with this pandas. And as well for Seaborn, just replace that with Seaborn. So that's it for to install those library or dependency. So now we have to import our datasets. Okay. So to load our dataset, so let me assign a variable for it, coffee sales datasets. So we'll be using pandas.readExcel because it's an Excel file. So read Excel, then put arrow for raw string, then quote. So let me bring in the file. Okay, right click on it and click copy as path. Then paste the path here. So remove this double quote. Okay, so we are going to assign this to a data frame. We are going to copy it. The reason why I always like doing this is because if we were to make a mistake, we can always revert back to this. Because if you're being presented with a real world dataset, particularly in Excel, and you didn't duplicate it, and you were to go ahead and make a mistake, that means that data is useless, particularly if you have saved it. So always copy from the raw dataset. Always copy from it. Don't use it directly. So coffee sales dataset dot copy. So you'll be copying it. Then let's see the first five and the last five. Okay, the dataset is loaded. So let's expand this. So this is how the dataset looks like. So we have the index, we have the transaction ID, transaction date, transaction time, transaction quantity, store, as well as the rest. So we'll be creating some calculated columns here because we don't have sales columns here. And also let's see if the data is clean so that we can do some data cleaning. Okay, so let's check the info, def.info. Okay, so as you can see, we have all the data points which are complete. So all the way from index 0 all the way to 149,115. So we have a total of about 149,116 records. So this is complete and the data type as well is correct. And also we'll be doing some calculated field here, like I said. So now see this transaction date here and this transaction time. We are supposed to merge them together into date time object. So that means we'll be removing this and appending it to this. So let's quickly do that. And also let's check for duplicate first. Let's check for duplicate and as well as null value to validate that what I'm saying is accurate. df.duplicated, so dot sum. So to aggregate all duplicate values, 0 duplicate value. Let's check for null as well. df dot is any. You can use this any, we can use this null, so it's still the same. Okay, so as you can see, we have 0 null values in all the row columns. So that means our data is clean. So now let's create those columns I said. So now the first column which we are going to create is the sales column. So let's do that. df sales. So for us to get the sales column, we have to multiply the df quantity df transaction quantity QTY multiply by unit price. Okay, so let's check if the column is created. df dot head. So we want to see the first 5. Okay, so we have the sales columns here. So like I said earlier, we are going to convert this. We are going to merge these two together. So let's quickly do that. So to do that, we have to do some things here. So we are going to reassign it back to this. So df transaction date equals, so we'll be using pd dot to date time. I'm going to explain this. pd dot to date time. So what we are going to do here is we are going to bring in the transaction date, which is of type date time object. So we are going to change the data type to type string. So str, then we are going to concatenate with a space, double quote, space, so space. So df, we are going to merge it together with transaction time. So we convert this to type string as well as type string. So now what's happening here is that once we concatenate or merge these two columns together, it's going to be of type string. So that means we are converting from date type, or from this date time object, which is this, to of type string. So now from this type string, we are going to merge it together. So it's going to be type string plus type string. So it's going to be one full string. So then we now use pd dot to date time to convert it from this string object to a date time object. So that's the logic here, because you can't just convert it directly like that, particularly if you are merging these time objects here. As you can see, this time object is just of type object, not of type date time. So that's why I have to convert both to type string, then convert it back to date time. So that's what's happening here. So let's load it. Okay, it's loaded. So let's verify. So let's run this and verify. So as you can see, the two has been merged together. So we are going to drop this column here. So let me quickly drop it. df dot drop. So we are dropping what? We are dropping a column. So which column? We are dropping the transaction time column. Transaction time. So in place, that means we want our changes to take effect. In place equals true. Run it. Okay, so let's verify if this works. Okay, so that column has been dropped. So let's check if our data type is correct as well. It's of appropriate data type. So as you can see, we're on the right track. So now, the first business question, which is, what is the total revenue? So let's quickly get that. So what is the total revenue? So to get the total revenue, we have to sum this sales column here. So df, so sales dot sum, the sum method. So run. Okay, so now, okay, let's format this appropriately. So we are going to use the formatted string to format this properly. So f double quote, right, the total revenue is $. Then place this value, remove this quote, place this value inside the curly brace, then close the double quotes. Okay, so let's run it. So as you can see, it's looking nice, but let's turn this into an appropriate format. So to do that, we're going to put the, then write comma dot 2f, so to two decimal place. Okay, let me remove this space here. So to do that, just put the less than sign here and run. So as can see, our total revenue is $698,812.33. So this is more readable. Now the second business question, which is what is the total quantity? So to get the total quantity as well, we have to do formatted string. So the total quantity, then open curly brace. So it's going to be df, then transaction quantity dot sum. So the sum method. So let's run this. Documentation. Run it. Okay. So now let's denote the 1000 there. So it's going to be 0 because quantity is not in fraction. Okay. So now the third KPI question, average order size. So we are going to divide the sales column with this transaction ID count. So let's do that. Okay, so formatted string, the average order value is, so our curly brace, df, so sales dot sum, then divide by df square brackets transaction ID. So we have to get the unique values dot n unique. So n unique is going to return the unique values and it's going to count them. So that means number of unique values. So now let's put this in brackets. So let's format it. So comma dot 2f. So to remove the spacing, run. Okay, so the average order value is $4.69. So we have answered our main KPI question. So now let's dive into our KPI drivers. So the first KPI driver question is, which store contributes the most to revenue and which is underperforming? So let me copy the question. So to answer this business question, we have to group our sales column by the store location. So to do that, we have to use store location revenue equals, so df dot group by, we have to go by store location. So store location, let's verify that. So store location, then the sales column, so dot sum. So let's see. Okay, sale column not found. Let's confirm. Okay, sales column, sales. Okay, so let me convert this into a data frame. That reset index and run. Okay, so from this you can see that there's not much difference within this here. There's not much margin here. So we have about $232,243 in Astoria. Then we have about $236,511 in Hell's Kitchen. Then in Lower Manhattan, we have about $230,057. So for Lower Manhattan. So as you can see, so let's Hell's Kitchen is one that is performing best, then followed by Astoria, then followed by Lower Manhattan. So no store is underperforming. So let's plot this. Let's plot this and see. So dot sum. Let me remove this. Dot sum dot plot. So kind. Let's plot this as bar charts. Bar. Okay. So plt dot show. Okay. So as you can see, there's not much difference within this column chart here. There's not much difference within this column here. So we can be able to answer our business question that there's not much difference, there's not much margin between the three store location. So now the next KPI question, KPI driver question, does customer preference differ by store location in terms of quantity? So let's do that. So Control C. Okay. So now what we are going to do here is that we are going to group each store location and product and also the quantity ordered for that particular product. Then we are going to sort in order to see which product is the most ordered product in each store. Okay, so let's dive in. Okay, so store preference. Store preference. So df dot group by so we are grouping by store location first, followed by product type, then want to aggregate the quantity, transaction QTY dot sum. Let's run this. Okay, so now let's sort it. Let's sort it and also reset the index. So we convert this back to a data frame dot reset index. Okay, so now let's sort it. So preference dot sort values by, so we are sorting by this transaction quantity in descending order. Ascending false. Okay, let's run and see. Okay, so as you can see, in Astoria, the most popular product by quantity is brew chai tea. Then in Hell's Kitchen, it is barista espresso. And in Lower Manhattan, it is gourmet brewed coffee. So those are the three top products in each store. This, followed by this, then followed by this. Okay, so let's proceed over to the next business question. So what are the top 5 products that contribute the most to revenue and bottom 5? So let's answer that question. Okay, so let's tackle this individually. So let's check for the top 5 products, then we will check for the bottom 5 products. So top 5 products by revenue equals df dot group by So we are grouping by product type. Then aggregating the revenue, which is also the sales column, dot sum. Okay, let's run it. Now let's see it. Top 5 products. So we are still going to sort. Okay, we have lots of them. So let's sort and check for the top 5. So top 5 products dot sort values in descending order. Ascending equals false. Ascending equals false. Okay. So let's rerun this. Okay. Now let's check for the top 5. Dot head. So head is going to display the top 5 implicitly. Okay, so the top 5 products is Barista Espresso, then followed by the Brew Chai Tea, then followed by Hot Chocolate, Gourmet Brew Coffee, and Brew Black Tea. So those are the top 5 products that are generating most of the revenue. So now let's check for the bottom 5. So for the bottom 5, you are still going to copy this code here and Control C. I didn't copy. So copy, Control C, then paste. So instead of us seeing the head, we want to see the tail since we have sorts in descending order. So the tail. So let's run and see. Okay, so the bottom 5 product is black tea, followed by sugar-free syrup, then followed by organic chocolate, green tea, and green beans. So as you can see, so those are the top 5 and the bottom 5 products. So we have been able to answer our KPI driver questions. So now we go into time analysis. So now the first business question for time analysis is, what is our growth trend like across months? So to do this, since we don't have the month column here, so we don't have the month column here, but we have the date column. So we are going to extract the month column from this date column here. So let's quickly go ahead and do that. Okay, so now I'm going to be extracting 2 columns. So the first column is going to be month name, then the second column is going to be month number, because we want to sort the data in chronological order, not in alphabetical order or in revenue order. So now let's do that. So to do that, write df, then month underscore name equals. So we'll be using df, the transaction dates. So we'll be using the dt, which is date time accessor, to extract the month name. So the dt dot month name. So let's run this and see first. Okay, so as you can see, we have our month name. Now let's get our month number. So month underscore no. So equals, so df, so transaction date dot dt accessor dot month Okay, so this one doesn't need brackets. So let's confirm. Okay, so the business question again, let's go over it. What is our growth trend like across months? So to do that, we have to group by. Okay, so df dot group by. So we'll be grouping by month number and month name. Then we will aggregate with sum. So month number, comma, double quote, month underscore name. Then we will aggregate the sales colon with sum. Run it. Okay, so as you can see, our data is currently in chronological order. Okay, so let's plot it. Dot plot kind equals line. Then we want grid line. Grid equals true. Grid equals true. Then I want the fixed size to be, the width should be 10, while the height should be 5. Let's run and see. No, before we run, let me use plot.show. Okay, so as you can see, we have February as the least sales month. Then we have June as the peak sales month. Okay, so we have been able to answer this business question. So now we will check what is the month-over-month growth rate. So to do that, let's do that. So we are still going to follow this same approach. So it's going to be df dot group by okay, dot group by okay. So df dot group by, so square bracket, month number, comma, double quote, month underscore name. So we'll be grouping by sales. So dot sum. So let's say it again. Okay. So now what we'll be doing is that we'll be turning this into a data frame. So let's turn it into a data frame. Reset underscore index. Now let's assign it to a monthly sales variable. So let's run it and see. Okay, so we're on the right track. So now what we are going to do is that, so now we'll be creating a column which will be month over month, MOM, equals, so we'll be using the sales column to achieve that. So it's going to be monthly sales, then the sales column, then we will call .pct change. So let's run this. So monthly sales. Okay, so as you can see, you're on the right track. So let me multiply this times 100 to see it in percentage instead of the decimal. Okay, so as you can see, in February, we said 6% less compared to January, while in March, we sell 29% more compared to February, and in April, we sell 20% more, then May 31% more, and in June, we sell 6% more. So this is the month-over-month growth rate, or this is the month-over-month growth. Okay, so we have been able to answer the second business question. So now let's go over the third business question. Let me copy this. Okay, so now for the next business question, which top 3 products sell month over month? Okay. So now, to do the top 3 products in each month, we have to go back to our original data frame. Let's assign this to a variable. So it's going to be product monthly product monthly sales equals, so df.group by, so we will be grouping by month number, then followed by month name, then followed by product type. So we will be aggregating with the sum sales. So aggregate with sum. Okay, so let's run this. Okay, so now let's reset the index. Let's put our opening and closing brackets here. And run. Okay, so now you can see we have all the top products or the products in each month here. So we only want the top 3. So to do that, what we'll be doing here is that we will be ranking these sales here. We'll be ranking these sales with top 3 numbers. We'll be ranking it. So to do that, we are going to create a new column, which will be rank. So rank equals explain the type of ranking which we'll be using. So we'll be using the dense rank. If we were to use the normal rank method, it's going to skip some number if there is a wide gap between the two numbers. It's just like having, if we make a sales from a product about $10,000, let's say it's going to rank it 1. Then the next product that follows it in order, which let's just say the next product is 5,000. So instead of ranking it 2, it might rank it 3 or 5. So that's the issue with ranking. But we want to rank without gap. That means we want to rank by 1, 2, 3. So we don't want any gap between those numbers. So we'll be using the dense rank. And also, if we be using the rank here, we want to partition by month number and month name. We don't want it to just rank everything as a whole. You know that we have different products in different months here. So we are going to group by month number and month name. So now let's quickly do that. So it's going to be product monthly sales dot group by. So we want to group by month number, comma, month name. So sales. So instead of us aggregating, we'll be using the rank method. Sales dot rank. So which type of rank we'll be using? We'll be using the dense rank. So it's going to be dense rank. And how do we want it? We want it in descending order. So rank it in descending order. Ascending equals false. Let's run it and see. Okay, we are on the right track. So now what we'll be doing now is that we'll be sorting by month number and rank. So now let's do that. So dot sort values. So we'll be sorting by month number, then followed by rank. So ascending equals true for the month number and also true for the rank. So let's run it and see. Okay, so it's working. So now we are going to filter for the first three, which are the top three products in each month. So now let's reassign this back to itself. So product monthly sales equals. Now to filter, we are going to use product sales, then open a square bracket, write product sales. So we'll be filtering by rank. So rank column, rank is less than equals to 3. Okay, so let's run it and see. Okay. So as you can see, in January, we have the Barista Espresso, then followed by the Brew Chai Tea, then followed by Hot Chocolate. Then starting with February, we have Barista Espresso again, Brew Chai Tea, Hot Chocolate. So as you can see, this is consistent. Barista Espresso, Brew Chai Tea is consistent. So except for June, so the third product that is ranking is government brewed coffee. So we have been able to answer this question as well. So now, over to the next question. What day of the week do we generate the most revenue? Okay, so now we are looking for the peak sales day. Yes, peak sales day. So let me copy this business question. Okay. So now what we are going to do here is that if we were to check our original data frame here, we don't have. So now we are going to use the date time here, which is this transaction date, to bring that out as well. So it's going to be df day underscore name equals df transaction date dot date time accessor dot day name. Okay, so let's see it. Let's verify. Okay, so now we have the day name here. Okay, so let's bring in our day of the week. So df square bracket DOW, day of the week, equals df transaction date dot dt dot day of week. Okay, so let's run it and see. Okay. So it's running properly. Okay, so now we are going to group by. So df dot group by so we'll be grouping by day of the week, DOW, comma, and day name. Then we'll be aggregating the sales dot sum. So let's run it and see. Okay, so it's sorted in chronological order. So now let's plot this. So dot reset index. So day sales trend. So day sales, let's run it again. Okay, so now let's plot this. So to plot it, we're using the plt.plot. So for the x-axis is going to be day sales trend, then the day name column. Then for the y-axis, so it's going to be day sales trend, so with the sales column, plt.show. Okay. So our peak sales day is Monday, then followed by Friday, then Thursday, while our least sales day is Saturday. So let me reformat this so that you can see it properly. So plt.figure fig size. So the width, let's make it 10, and the height, let's make it 4. So let's put grid lines. plt.grid through. Okay, so let's run it again and see. Okay, so our peak sales day is Monday, followed by Friday, while our least sales day is Saturday. So we have been able to answer this business question as well. What day of the week do we generate the most revenue? So we generate the most revenue on Monday. So that's it for that. Now for the last business question, what are our rush hours? Okay, so what this means is that time of the day in which customer order the most, which they place their order the most. So now we are going to go for the time of the day in which they placed the most order. So now to do that, we'll be using transaction ID, and also we'll be needing the hour column here. We'll be needing the hour column. But since we already have our transaction date being merged with time and date, or date time, so we'll be extracting this hour here from this. So now let's go ahead and do that. So it's going to be df. So we're creating our column equals df transaction date dot dt dot hour. Now let's run it and see. Okay, so we have it here. We have our hours there. So let's validate that. As you can see, we have 7. We have 7 here. It is 7 a.m. in the morning. Then we have 8 a.m. in the morning all the way to 8 p.m. at night. So we are using 24 hours here. That's why you can see p.m. and a.m. So that's 24 hours. So okay, so now let's check for the time of the day in which we sell the most. That means by the number of order placed. So now to do that is going to be df dot grow by. So you'll be grouping by hour. The hour column. Then now what we are going to do here is that we'll be grouping by quantity placed for each hour. So what we'll be doing here is that we'll be using this transaction ID to check the count of transaction placed hourly. So now we are going to write transaction underscore id. I should have used dot count or dot size directly here, but now let's assume that this data is duplicated. Let's assume that this data is duplicated, although I already know that it is not duplicated because we did our data cleaning, but let's assume that it's duplicated. So if multiple transactions are representing the same transaction ID, is going to skew this analysis. That means we will be presented with a result that is not accurate, according to our analysis. So we'll be presented with a result that is not accurate. So now to avoid that, we'll be using .n unique. N unique. So this n unique here means number of unique transaction ID. So anywhere it sees two transaction ID, it's going to remove it and just choose one out of it. So that's what this n unique means. So now let's put it in brackets and run it. Okay, so even judging from this, you can see that we have most of our peak sales around 10 a.m. then followed by 9 a.m. So it's between 7 and 10 a.m. That's where we have our rush hours. Yes, that's where we have our rush hours. So let's present this on a line chart. So dot plot. So kind, we want it as line, then grid to be true, then fig size, so we want it 10 by 4, and let's run it. Okay, so from here you can see around 7 a.m. we have some sales, then followed by 8 a.m. and our peak sales hour is around 10 a.m. followed by around 9, then around 8. So we have our rush hours between 7 a.m. and 10 a.m. So guys, we have been able to answer all these business questions. So if you do have any question, just write in the comment section. I'll be sure to reply that. So be sure to like this video, subscribe, and turn on your notification bell so that next time when I post a new video, you are going to receive a notification. So have a great day, guys. Bye.